Hey guys, I'm going to redeem myself on that last question. I saw the answer was C, and I was like, I have no idea how I could get that, but I was reading out of the wrong book. So anyway, let me redeem myself. Sorry about that. I do make mistakes. R here is 0.84, and then they're asking what would be the correlation be between these two expressions. And so the answer is actually A, which actually makes sense that it's not going to change. Our correlation value, no matter what you make X and Y, when we transform data, meaning add numbers to it or multiply numbers to it, it doesn't change our R value. And this should be a question in good context. So I was kind of misinterpreting what they were asking here. When we transform data, R stays the same. Okay, so this actually makes more sense. And so that'd be a fair question. They're just, I don't necessarily, without knowing X and Y, I don't know what those graphs would look like, but I know that R would not change. Okay, so let's go on to chapter 4. How do I collect data correctly? So let's take a look. A political polling group is interested in learning about the proportion of registered voters who favor a political candidate. Which of the following sampling plans may have introduced bias? Okay, so our notes are going to be pretty useful here as we hone in on what could be bias. So a survey was mailed to all registered voters, and those who returned the survey make up the sample. If we look here, we notice that this is introducing non-response bias, right? And that was one we talked about today. All right, question number 2. Which of the following is not a necessary component of a well-designed experiment? All right, so we know we have to do a treatment or it's not an experiment. We need a treatment. We know we need random assignments, right? Or we can't say causation. We know it has to be replicated. So I think in AP Psych, we hear about this. You need to be able to make an experiment so that another scientist can replicate it. We know we need to control other variables. You just learned that in science. So the only thing I don't need here is E, random selection of the subjects. All right, I could have an experiment and I could have all volunteer subjects. So, and because of that, that's why I have to use random assignment, because I can't force humans to do things. Okay, question number 3, which of the following is always problematic in a design experiment? So what is going to be a problem no matter what, an unavoidable problem? If we look here, we don't necessarily, it's totally okay. There's many experiments that don't have placebo. So systematic sampling is used instead of random sampling. That doesn't make sense. I can use, so that's not always going to be problematic. Subjects are not randomly assigned. Yep, so as we said above here, if your subjects are not randomly assigned, that's going to be a huge problem. That is a required component of an experiment. Random assignment is required. So if you're not doing random assignment, that's going to be a problem. Question number 4, a garden club wants to use a fertilizer on their prime petunias to increase the number of petunias produced per patch. A club member suggests that they set up an experiment to see if this fertilizer is better than the fertilizer than they've used in the past. The patch is divided into 8 sections in order to run this experiment. So here's the patch. Four of the sections receive more sun, while the other 4 received more shade. So apparently, you know, maybe there's some trees here. And so these 4 get more shade, and these are in the direct sun. So this is like why we would do blocking. We would want things that we know that happen to be alike from one another. We want to make sure we either randomize, or we know that we might accidentally get fertilizer, the new fertilizer in the shady section or the good section. So we want to be equal with that. Okay. So when we see this, we see that B, the number the 4 sections, and then we want to randomly assign the new fertilizer to 2 sections in the sunny side, and then randomly assign to the 2 sections in the shady side, repeating the process for the shady side, and this will allow for that to be equal parts to each section. So we can think of this too, that I have as kind of a block design. I have my 8 plots, right? And this isn't random assignment. I have the sunny ones and I have the shady ones. And then I want to use random assignment. Random assignment, maybe the first 2 that I pick get fertilizer 1, and then the other get fertilizer 2. And again, random assignment here, random assignment. And then randomly assign fertilizer 1 and 2 to 2 equal plots there. Then I'm going to compare results. And then compare results again. Compare results with the sunny ones, compare results with the shady ones, and compare the results from all the sections. What is the best reason to recommend the use of a placebo? Okay, so we know that a placebo effect is when the subjects respond favorably even without a treatment. So this would be used when there isn't an existing treatment and you want to be sure that the effect seen is not just due to the fact that they feel like they're being treated. You have a headache, I give you a Tic Tac. Tic Tacs don't relieve headaches. And your headache gets better all on its own. It's a way to make sure that if you're getting better, the reason why you're getting better is that item. And you'd have to kind of design an experiment in a blocking and give people the placebo to just make sure that their improvement is not just because they happen to improve. Question number 6, 2 variables are considered to be confounding. Okay, so when I have confounding variables, our notes say that that's when I have an explanatory and a response, and this confounding variable is affecting both the explanatory and the response. All right, so as we look here, if the effects on the response variable cannot be separated, all right, so we somehow can't decide if this is not what is affecting the outcome, that it is in fact the confounding variable affecting the outcome, not the response variable. Okay? It can't be E because we're noticing that there seems to be a relationship between all 3 of these. The confounding is somehow muddying up the waters here. So we talk about this in our notes, that student motivation could be affecting what type of review they choose, and student motivation could also affect their score. So their effects on the response variable can't be separated. We can't separate whether or not it's the review or whether or not it's the student's motivation that's affecting the AP score. Now, 7, a key difference between an observational study and an experiment is always our treatment. Okay, so let's see if that would be one of our choices here. Yeah, the assignment of a treatment to our experimental units, that's how we know. So again, just jot something out on the side. Treatment tells us it's an experiment. 8, which of the following does not result in some kind of bias? So this is going to tell us that all of these do except one.